Hey, hey! Since Grace is away on holiday, is there anybody that wants to sing the theme song?
Can I do it, Daddy?
Yes, of course, Ben! Go for it!
It's time for Maths with Mr. Thomas.
Thank you very much, Ben! Here we go with Chapter 7, Lesson number 10. The sine rule and the cosine rule. A mixture. In the last few lessons we've been looking at the sine rule to work out the length of a side and the size of an angle, and we've done the same thing with the cosine rule. But often in the exam they do not tell you which one to use. They don't say, use the sine rule, or they don't say, use the cosine rule. You have to decide for yourself which formula you use. And in the exam you are given three formulas. You are given the sine rule to work out the length of a side, you are given the cosine rule to work out the length of a side, and you're also given the cosine rule to work out the size of an angle. And you have to decide which formula you use. You're not given this one, the sine rule to work out the size of an angle, but if you know the side, it's dead easy to work this out. Who remembers the sine rule to work out the length of a side? I do. Go on, John, what is it? A over sine A equals B over sine B equals C over sine C. Yes, you're right, John. Good. And the lowercase letters represent the sides, and the capital letters the angles. Well done. Good. And when you're using the sine rule, you need to look for your pairs. Remember, it's when you have an angle and the side across from it. They would be a pair. If you remember this formula, well, you don't need to, it's given on the exam sheet and the formula sheet, but it's dead easy then to use the sine rule to work out the size of an angle, because all you do is you flip this upside down. You're right, Julia, yes, flip it upside down, so it becomes sine A over A equals sine B over B equals sine C over C. Again, you look for pairs, an angle and side across from it, and the same as before, the lowercase letters, the small a, b and c, represent sides in the formula, and the capital letters represent angles! Yeah! There's also the cosine rule to work out the length of a side. Carrie, do you remember that? Yes, it's a squared equals b squared plus c squared minus 2bc cos a. Yes, well done, Carrie. Good. And same as before with the sine rule, the lowercase letters represent sides. Yes, well done, Carrie. And the capital letters, angles. Yeah, well done. Good. That is given on the formula sheet in the exam. And there's also, on the formula sheet, the cosine rule to work out the size of an angle. Who remembers that? I do. Go on then, Bobby. What is it? Cos A equals b squared plus c squared minus a squared over 2bc. Well done, Bobby. Yes, got it in one. And Bobby, the lowercase letter size. Yes. And the capital letter angles. Well done, Bobby. Yes, you've got it. And as I said, these three formulas here are given in the exam. This one is not, but it's dead easy to work out because you just flip it upside down if you're wanting to get the size of an angle. The problem comes, as I said, if you're given an exam question, it may give you something that looks like this. With a wee picture of John there beside it. But it doesn't tell you which formula to use. If you're looking back, you're thinking, I've got these three formulas. Or four formulas even, because I can flip this. And I don't know which one to use. So here is a way to work it out. What I always think about is, you've got the four formulas, and I always start with the cosine rule. And you use the cosine rule if you know all three sides, or if you know two sides and the angle between them. So always, whenever you get a question, going back to this one, have we look at it. If you know all three sides, do you know all three sides? Well, no, you don't, because you don't know this one. But if you know all three sides, or if you know two sides and the angle between them, then it's going to be the cosine rule. So for this one here, it would be cosine. Why? Because you know two sides and the angle between them. Perfect, yeah. So use the cosine rule if you know all three sides, or if you know two sides and the angle between them. And if it's not the cosine rule, it has to be the sine rule. It does have to be the sine rule, yes, well done. And for the sine rule, Z, what do you always look for? That's when you look for pairs. It is indeed, yeah. You look for pairs, which again, it's the angle and the side across from it. Let's try a few exam-style questions then, working this out. Here we go. So example 1, calculate the size of the angle marked X. So here is angle X. Bam, bam, bam. And once again, you want to think, is it sine rule or is it cosine rule? And the way I always do it, as I said, is to think of the cosine rule first of all. So use the cosine rule if you know all 3 sides or 2 sides and the angle between them. So here, do we know all 3 sides? No, we don't. You're right, we don't. We know this is 13, we know this is 18, we don't know this side. It is unknown, so we're not using the cosine rule if we know all 3 sides. Do we know 2 sides and the angle between them? Well, we know 2 sides. And do you know this angle between them? No, we don't know that either. Good, that is also unknown. So we don't know all 3 sides, we don't know 2 sides and the angle between them, so we cannot use the cosine rule, which means it has to be the sine rule that we use. And for the sine rule, what do we always look for? Pairs! You do indeed, yeah, you look for pairs. So the pairs are when you've got an angle and you've got the side across from it. Because we are asked to work out angle X, that has to be one of our pairs. And the side across from that is 18. And the other pair would be, yeah, it's going to be the 35 degrees and the side across from it, which is the 13. Good. You are wanting to work out the size of an angle using the sine rule. So remember, take the formula that's on the formula sheet and flip it upside down because it's the angle you want to find. So we've got sine A over A, sine B over B, and sine C over C. So if we're starting to work this out then, we know it's the sine rule. We know it's the sine rule working out the size of an angle. And because it's an angle, the angles are going to be on top. In this formula here, remember the capital letters represent the angles. But here, the angle we are calling is X. So we're going to start off saying that sine X over, and what's X paired up with? 18. Good, the lowercase letters represent the sides. Good, so it's going to be sine over angle X. Sine X will be over the side 18. So sine X over 18 would equal, and then look for another pair with sine of the angle over the side. So the other pair is 35 and the 13, so it's going to be sine 35 over 13. Woo! We're wanting to get sine X on its own first of all, so how do we get rid of divide by 18? Times by 18. Yeah, you do. You would times that side by 18. But in order to keep it equal, you would also have to times this fraction by 18. And when you're multiplying, it really just goes on the top. But rather than putting it after the 35, and then your calculator might do the sine of whatever 35 times 18 is, just put it to the front. So it's going to be 18 times by sine 35. So multiply this side by 18. And we're left just with sine X, because divide by 18 and times by 18 cancel out. And on this side, if we're times by 18, put it on the top. So it's 18 times sine 35 divided by 13. On the calculator, you end up with 0.79418 and so on to quite a few decimal places. Keep that answer on your calculator. And then how do we get X and so on? Sine to the minus 1. Good, so X would equal sine to the minus 1 of that answer there, that previous answer. Again, keep that on the calculator. Don't do sine to the minus 1 of 0.8 or 0.79. Keep it as accurate as you can. And if you work that out on the calculator, it gives you an answer of 52.58. And it's an angle that we're working out. So the units are degrees. Well done, good. So it's 52.58 degrees. Shall we try another one? Yes, please. Example 2, calculate the size of the angle marked G. There is G, there is the angle you are wanting to find. Once again, we are not told if it's the sine rule or the cosine rule. So what I always think about is the cosine rule first of all. And as it says here, use the cosine rule if you know all 3 sides or if you know 2 sides and the angle between them. So here, do we know all 3 sides? Well, yes, we do. We know that side, we know that side, we know that side. We know all 3 sides. Woo! Which means it's going to be the cosine rule. There are 2 cosine rules on the formula sheet. There's the cosine rule to work out the length of a side or the size of an angle. Which one's this going to be?
It's going to be the size of the angle because it's the angle we want to find.
Obviously, yes, it's the cosine rule to work out the size of an angle, which is the cos A equals b squared plus c squared minus a squared over 2bc. On the formula sheet, in the formula, remember the lowercase letters represent the sides and the capital letters represent the angles. Because this here is the only angle we are wanting to find, this here then has to be our A. So you can imagine that just as angle A in the formula. And because of that, if this was angle A, across from that would be our lowercase a. So when we're putting this into the formula, it's going to be cos of this angle here, which we're calling G. So we're going to have cos G equals B squared plus C squared minus A squared. What's that going to be? Well, the B and the C, it doesn't matter which one's which. One of them's 100, one of them's 88. All we know is that the A has to be the 57, and the A is the one we are taking away. So we've got 100 squared, 88 squared, which we would add together in either order, and then we're taking away the 57 squared. And we're dividing that by 2 times B times C. And remember, the B and the C are the two sides either side of the angle. So it's going to be 2 times by 100 times by 88. Or again, back to front, 2 times 88 times 100. Makes no difference whatsoever. If you type that into your calculator, good, you get 14,495 divided by 17,600, and if you work that out to a few decimal places, you end up with 0.82357, blah, 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 blah. But remember, that's not your final answer. That angle there is not 0.8 degrees. How do we get the size of the angle? What do we do?
That's when you do cos to 9 as 1.
You do indeed, yes. So to get G just on its own, you do cos to the minus 1 of that decimal. And if you type that in, boop, 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 you end up with 34.56 degrees, which is a lot more sensible. It's more likely to be that than 0.8 degrees. So don't stop at 0.8. You know that's obviously not 0.8 degrees. Yes, it's more likely to be the 34.56. Woo! Let's try another one. Here we go, example 3. Calculate the length of the side H. Dun, 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 dun. Once again, here we go. This is what we're wanting to find. We want to find H. We're given this triangle. It is not right angled. We know the length of this side. We know these two angles. And we're not told if it's the sine rule or the cosine rule.
Oh no, what do we do then?
Well, David, I will help you out. What you do is you always think about the cosine rule first of all. And you use the cosine rule if you know all 3 sides, or if you know 2 sides and the angle between them.
Okay.
So, do you know all 3 sides, David?
No.
Correct. You do not know all 3 sides. Or do you know 2 sides and the angle between them?
No.
Correct. Good. We don't know 2 sides and the angle between them. H is unknown. We only know 1 side. So we cannot use the cosine rule. If we cannot use the cosine rule, what are we going to use? Sine rule! Woo! And the sine rule is when you look for your pairs. Are you going to use the sine rule to work out the size of an angle or the length of a side? Yeah, it should be quite obvious. It's the length of the side that we are wanting, so it's the sine rule to work out the length of the side, which is given on the formula sheet. A over sine A equals B over sine B equals C over sine C. And once again, in the formula, the lowercase letters represent the sides and the capital letters represent the angles. Here we go. We're wanting to work out the length of the side H then. So, for the sine rule, you need to think of pairs. Good, you think of pairs. And because we're wanting to find H, we would start with that. And what is H paired up with? Well, because that's the length of that side, the angle across from that side is 113. So start with what you want to find. We want to find H, so we're going to have H over sine of our angle. So it's H over sine 113 equals, and what's another pair? What other pair can we use? Well, we've got this 32 degrees and we've got this 6 centimetres across from it. So that will be the pair. What goes on top?
The side.
It is the side, yes. Look at the formula. You can see the lowercase letters represent the sides. The side is on top. So 6 goes on top. And then it's sine over angle on the bottom. Good. So it's going to be sine 32. We are wanting just to get H on its own. How do we go about getting H on its own? Good. You'd multiply by sine 113. So if you multiply the left-hand side by sine 113, leaves you with H, but you'd have to do the same at the other side as well. And when you multiply, it just goes at the top. So you'd have the 6 times by sine 113. and we're still dividing it by sine 32. Notice how the 6 is on top and the 6 is staying on the top. The sine 32 is on the bottom and the sine 32 is staying in the bottom. All we're doing is we're multiplying by the sine 113. If you work that out, you can key that into your calculator. And you end up with 10.42 centimetres to a couple of decimal places. And that is the length of the side H. Woo! Let's try another one. Example 4. Calculate the length of the side Y. Once again, it is going to be sine rule or cosine rule, but we are not told which one to use. So, do our wee check once again. Think about the cosine rule first of all.
Oh, I love that cosine rule. It makes me feel all warm and fuzzy.
Thank you, Lee. But moving on, use the cosine rule if you know all three sides or if you know two sides and the angle between them. So here, do we know all three sides? No, we don't. We don't know all three sides. We know this is 9, we know this is 5, but why? Why do we not know it? Well, we don't. Or if you know two sides and the angle between them. Do we know two sides and the angle between them? Well, yes, we do. We know the 9, we know the 5, and we also know the angle between them there. So because of that, it would be the cosine rule that we are going to use. Is it the cosine rule to work out the length of a side or the size of an angle that we want? Well, because we want the length of a side, it's obviously going to be the cosine rule to work out the length of the side. So it's not the one where it's cos A equals, it's the other one. A squared equals B squared plus C squared minus 2BC cos A. And in the formula, lowercase letters represent sides and capital letters represent angles. Good, well done. If you look at this formula here, the only capital letter we have is this one. It's the capital A. And the only angle we have in our triangle is the 70. So that there has to be our angle A. And if that there is angle A, what is that side across from it going to be? Lowercase a. It will be lowercase a. Good. And that is what we are wanting to find. We want lowercase a, which we're calling in this case y. So we're going to have then to start with y squared equals, so instead of a squared, we've got y squared equals b squared plus c squared. Well, what are b and c? Yeah, they're just the other two sides. Good. If this is side A, side B and side C are the 5 and the 9. Again, it does not matter which is which. So you'd have the 9 squared plus 5 squared minus 2bc means 2 times b times c. So it's 2 times the 9 times the 5 times by cos of the angle. And the angle here is 70. So it is cos 70 on the end. If you work that out on the calculator, beep, 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 you end up with 75.218. And that is going to be what y squared is. Is that the final answer then, Sarah? No? Why not? Yeah, good. Obviously, if this is 9 meters and this is 5 meters, there's no way that's going to be 75. And that is y squared that we have worked out. We don't want y squared. We want y just on its own. So how do we get y, Sarah?
You take the square root.
You do take the square root. Good. So y on its own, take the square root of both sides. Y on its own is the square root of the 75.218, blah, 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 blah. Again, keep your answer really accurate on the calculator. And if you work that out, beep, you end up with 8.67 centimetres. Yeah. Woo! Well done, people. Shall we try more?
Yes, please.
Example 5. Calculate a length of the side M in this funky yellow triangle. We're not told whether it's the sine rule or the cosine rule.
Yeah, but you can do your check. Remember, your check is when you always think about the cosine rule first of all.
It is indeed, yes. So if I think about the cosine rule first of all, what do you look for with the cosine rule?
You look to see if you have all three sides or two sides and the angle between them. And if it is, then you would use the cosine rule.
Yeah, you're right. Well done, Alistair. Good. So, cosine rule, do you have all three sides? No, you don't. Do you know two sides and the angle between them? Well, no, we don't. We've got the M and the 33, but we don't know what this side is. It is still unknown, so we cannot use the cosine rule. And if we can't use the cosine rule, we have to use sine rule. Brilliant. And the sine rule, because we're wanting the length of a side, it has to be the sine rule side that we're wanting to find. The sine rule side is when you put the side at the top, so it's the lowercase letters at the top. It's the one that's on the formula sheet. So it's a over sine A equals b over sine b equals c over sine c. Again, lowercase letters at the sides, capital letters are the angles. So we want to always start with what we want to find. So here we would have m on the top, but we have to put the angle that is paired up with. Anybody see any issues with this?
Oh, yes.
And what's the issue? I don't know the size of that angle. You're right, you don't know the size of the angle. So what would you have to do? You can work it out. And how can you work it out?
Well, you know, two sides. So in a triangle, angles add to 180. So you could add the 60 and the 52 and take away from 180.
You can indeed, yeah, well done. So add the 60 and the 52, take that away from 180, and it means then that this angle is no longer unknown. We know this is going to be the 68 degrees. So we can start then using the sine rule. So start with what we want to find, which is the m. So we're going to have m over, and it's sine of the angle. So it's m over sine 68 equals, and what's another pair? Could we use the 60? Well, no, we can't. We can't use the 60 because we don't know the side across from it. So we can't use that pair because it's not a pair. But we've got the 52 here, and we've got the 33. That there will be a pair. We've got the angle, we know the side across from it, so we put that into the formula. We have got just the side on the top here. It's the side we want to find, so the side is 33, and we're dividing that by sine of our angle, so it's going to be sine 52. Woo! We are wanting just to get m on its own, so how do we go about getting m on its own? What do? Good, you'd multiply both sides by sine 68. So the left-hand side, if you times by sine 68, it gets rid of divide by sine 68. And on the other side, we'd multiply this fraction by sine 68. And when you're multiplying, again, it just goes on top. So it's 33 times by sine 68, divide by sine 52. Again, 33 and sine 52, just stay where they are, one on the top, one on the bottom, and we're multiplying by sine 68. If you put that into the calculator, you end up with 38.83 meters. Whoa, yeah, that's how you do it. Here we go, example 6, final one. This is a common exam style question. Ben and Millie are standing 300 meters apart. B for Ben, M for Millie. When they look up and see a spaceship,
Take me to your leader.
the angle of elevation is 40 degrees for Ben, whee, and 30 degrees for Millie, whee. Calculate the spaceship's height above the ground. So you're wanting the distance from here down to the ground. Bump. How do we go about doing that? Well, the first thing that you would do is you would think for the cosine rule, do you know all three sides? Nope. Do you know two sides and an angle between them? Nope. And then for the sine rule, look for pairs. Do you have any pairs at all? Nope, you don't. So it's not going to be as straightforward as just jumping into the sine rule or the cosine rule. What you need to do first of all is you need to work out one of the sloping sides. And the way that you can work out one of the sloping sides is you can work out this angle at the top easily enough. And the size of this angle at the top, how do you go about getting that? Yeah, good. You can add these two angles together and take it away from 180 degrees. So if we do 180, take away the 40 plus the 30, we get 110. So this angle here at the top has to be 110 degrees. Again, we are wanting to work out the height from the spaceship directly down to the ground, but there's no way of doing that without working out a sloping side first of all. And the way you get the sloping sides is you ignore this wee dotted line with the height, and you just imagine it as a whole triangle with 40, 30, 110, and then the 300 meters. And to get one of the sloping sides, let's say we want this one, imagine if this is a sloping side that we are wanting from B to S, then here we can use the whole triangle and we can think, oh, well now, use the cosine rule if you know all three sides. Yep, we still don't know all three sides. Two sides and an angle between them. Well, we don't know two sides and an angle between them, so it's definitely not the cosine rule. What we can do is we can use the sine rule. And when it's the sine rule, we look for our pairs. So because we're wanting to work out this side from B to S, that is going to be the length of the side, and it is paired up with the angle that is across from it, which is 30 degrees. Because it's the side we want to find, we think about the cosine rule for the side. A over sine A equals B over sine B equals C over sine C. But because we want to work out this side from B to S, put that first. So BS over sine of the angle across from it, the 30 degrees, would equal, and look for your other pair. We know this is 300 meters, and we know the angle across from that is the 110. So that would be, BS is the side, so we're putting the side in the top, which is a 300 over sine of the angle, and that's sine of 110 degrees. To get BS on its own, you're having to multiply both sides by sine 30. So you'd have 300 times sine 30 divided by sine 110. So multiply the left-hand side by sine 30, gets rid of divide by sine 30. And if you times the right-hand side by sine 30, you just put it on top. So 300 times sine 30 over sine 110. Work that out in the calculator and you get 159.62666 meters to equate to a few decimal places. Remember, that is not your final answer, so don't round it, keep it fairly accurate. What you now want to do is you want to ignore all of this. And once again, you're thinking it's the height that you want to find going from here directly down to the ground, but you can imagine then a wee right-angled triangle. And if you isolate just this triangle, well, what you found was this height. You know that was the 159.6 blah 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 blah. So if we ignore this part of the triangle here, then we're just looking at that left-hand part. So we've got the B and the S, we just worked that out. We know this is 40 degrees, and because you know it's a perpendicular height, you put in a wee box there to show that that there would be 90 degrees. Make sure whatever you do not say that this here is going to be 300 at the bottom, because it's the length of the whole triangle. We're splitting it up. We're ignoring this bit on the right. Also, don't say that it's 150. That's a common mistake in the exam. It is not halfway. There is nothing to say that the spaceship is halfway between them. So you do not say that this bit here is 150 meters. Do not do that. You have to just use this information you are given. But what could you do next?
Well, doesn't that just take it back to a National 4 question?
What do you mean a National 4 question?
Well, it's a right-angled triangle, and you know an angle and a side, so it's just SOHCAHTOA.
It is indeed, yeah. You can think about SOHCAHTOA. And remember, sine is the opposite over hypotenuse, cos is the adjacent over hypotenuse, and tan is the opposite over adjacent. Here then, because we've got this angle, the 40, across from that angle we have the opposite adjacent over hypotenuse.
It's the opposite.
It is indeed, yeah, it's the opposite. So this bit here, the height that we're wanting is going to be the opposite. Across from the right angle we have the, yeah, good. Across from the right angle is always the longest side. It's always the hypotenuse. And this side here is the adjacent. So it's the adj. You can see from here, we know what the hypotenuse is. We just worked that out. So we can circle the H for hypotenuse. The opposite is what we want to find, so we have to use O for opposite. We are wanting to find that. But the adjacent, do we know the adjacent? No, we don't. Do we want to find the adjacent? No, we don't. So we ignore the adjacent completely. Ignore the A's. And if you ignore them completely, the only triangle we can use is this one here with sine. So in order to find the height, it's the opposite we want to find. So what I would do is say that the height equals, and then if you look at the height as the opposite, so if you cover up O for opposite, we've got S and H on the bottom here. And what do you do when they're beside each other? Good, you would times them. Good, look back to the first lesson in this chapter if you want revision with SOHCAHTOA. The opposite is the height, that's what we're wanting to find. We've got S and we've got H beside each other, so to work that out in the calculator, you would do sine of the angle multiplied by the hypotenuse. But remember, put it in backwards. The hypotenuse, first of all, which is 159.62 blah 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 blah, that's our previous answer. Multiply that by sine of the angle, so times that by sine 40 degrees. And if you work that out in the calculator, boop, boop, You get 102.61 meters, which means that there is the height of this funky wee spaceship above the ground. It is the distance from the spaceship down to the ground. It's that 102.61 meters with the wonkiest line ever. As I said, that type of question there is fairly common in the exam because it's not just a straightforward use the cosine rule or use the sine rule. There's other bits that you have to consider. Woo! Good luck. Practice some of these questions in the book then. You need to know if you're using the sine rule or the cosine rule. Remember, as I said, always think about the cosine rule first of all. Use the cosine rule if you know all three sides or if you know two sides and the angle between them. If you can't use the cosine rule, it has to be the sine rule. And for the sine rule, you think of pairs! You do think of pairs, an angle and the side across. There's a good exercise in the TJ National 5 book, page 85. Good luck! See ya. Oh, Ben, you were so good at the theme song. Do you want to finish off? Do you want to do it one more time? Go for it.
It's time for math with Mr. Thomas.